Hello, my name is Blaine Katz, and I'm the project manager of the B.H.M.P engineering team. I have the pleasure of introducing you to the Spring 2015 Civil Engineering 495 project overview, as well as our talented members. The objective of this project is to construct a roundabout at the existing State Route 67 intersection at Highland Valley Road and Dye Road in Ramona, California. Our strategy is to create the most cost-efficient option with trying to achieve optimal traffic flow and improve safety through reducing traffic accidents and automobile emissions. As I stated earlier, my name is Blaine Katz, and I am not only the project manager, I also took on the responsibility of the geotechnical and hydrology needs of the project. Let us now introduce you to our stellar team of engineers.
Hello, my name is Hazem Sharour, and I'm responsible for the environmental needs of this project.
Hello, my name is Phil Veliker, and I'm responsible for the transportation analysis and design of the project, as well as our team's CAD specialist.
Hello, my name is Miguel Cruz, and I'm responsible for the construction management, scheduling, and cost analysis needs of our project.
Now that you know a little bit about who we are, I'll let each one of these gentlemen tell you about how they took on the different aspects of this project.
I'm Hazem Sharour, and I was responsible for the environmental study of the proposed project. The study mainly takes into consideration the California Environmental Quality Act, the National Environmental Policy Act, and the Clean Water Act. Potential impacts of this project were analyzed, and these consisted of impacts on 4 different areas: biological resources, noise, water quality, and air quality. Mitigation measures were carried out for these areas. Impacts on biological resources include any changes made to natural species, such as vegetation, plants, and animals. It was determined that the construction of the roundabout and road expansions will have no effect on vegetation. However, surrounding grasslands will be impacted. Restorations of a 3-to-1 ratio would be made to any affected grasslands or plants in order to preserve the existing habitat. Endangered species were not observed or located near the project area. Noise impacts will arise from the project construction due to blasting, pile driving, and other construction procedures. Mitigation measures, including sound wall installations, will ensure noise does not exceed 75 decibels in order to satisfy residents near the project area, even though there is a feasibility concern. In regards to water resources and water quality, best management practices, including fiber rolls, would be used to avoid runoff and water contamination. Also, several wells were found in the project vicinity, but not near the project construction site. Nonetheless, these wells will be protected or covered at all times to avoid any possible contamination that might occur due to their interference with construction materials. During construction, air quality will be affected, but upon completion of the project, air quality will be enhanced due to the improvement of flow, causing substantial reduction in vehicle CO2 emissions. The environmental study also included agricultural resources, solid and hazardous materials, population growth, and soil or geology concerns. However, the selected area and the project nature was determined to not have adverse effects on any of these factors. Benefits of undergoing and construction of a roundabout at State Route 67 and Highland Valley Road intersection will improve safety and reduce accident rates. The roundabout will also minimize stress and enhance usability by offering easy access to housing developments for the people of the city of Ramona. Improving the traffic flow would reduce the amount of CO2 emissions as opposed to constant stopping caused by the existing signalized intersection. This project, if implemented, will offer drivers an easier, safer travel and help improve the daily commute of the Ramona residents and the community.
I am Miguel Cruz, and I will be going over the construction management section for our project, specifically focusing on cost, the construction schedule, and our project phasing. The cost of this project was determined using Caltrans Cost Appendix, which is used by Caltrans for every road project executed in the state of California. In this cost analysis, we will be determining the cost of materials, engineering, labor, and maintenance cost. There are several factors that will affect the price of this project. First is the price of the winning bids, which will lower the overall estimated cost. Next, we will be focused on searching for recycled materials to find a better price and in order to help the environment. Finally, we will look into obtaining funds from local and federal grants to construct this roundabout. Here's a table representing the cost of this project. From the table, you can see the values that were deduced for this project. We'll determine our values assuming fair price on the materials. We shall then determine them in a way so that we can find the actual value, therefore dropping the overall price. We have also allocated a 5% contingency fund in order to accommodate for more expensive than expected values, unforeseen expenses, and other minor items. The schedule of this project was outlined using the Construction Management Association of America's Information Management Guidelines. The schedule offers parameters from the pre-design phase through post-construction. Here is the engineering schedule that we will be using to show the life of the project. Here, one can see the amount of days that each section will take to complete. It is represented using the Construction Project Management Activity on Node method. The top figure shows the way to read each node. In order for this project to be completed in the most efficient way possible, we have provided the construction phases necessary to be as effective in containing delays. This project will be broken down into 3 different phases that will allow access during construction. We have selected to break up the highway in half and allow access through the opposite side, and vice versa.
My name is Blaine Katz, and I am responsible for the geotechnical study for the proposed project. The purpose of this investigation was to examine surface and subsurface conditions of the site to provide the most accurate geotechnical design conditions needed for construction. The main areas that are addressed in our report consist of, but not limited to, soil classification, geological hazards, and road compatibility. During the site visit, it was observed that the elevation of the project site is constant throughout with light vegetation growth and scattered brush. The area has a mean annual precipitation of only 12 to 18 inches with no frequency of flooding. The soil was classified as a sandy loam, which is part sand, silt, and clay, with a parent material of weathered granite and landforms being swales. The slopes of the area are approximately 2 to 5%, with downslopes and cross-slope shapes being linear. Due to the flat landscape of the project site, frequent gusts of high winds occur on a regular basis, making erosion of the soil due to wind a concern. This brings us to analyzing geological hazards. The susceptibility of degradation rating describes the soil's risk of erosion through water, wind, salinization, solidification, and nutrient depletion. This can lead to not only erosion, but also a reduction in water and air quality. The California Geological Survey has developed a list of cities affected by surface fault ruptures, referred to as the Alquist-Priolo earthquake fault zones. The city of Ramona is not mentioned on the list because the CGS has determined that the faults around Ramona do not present a risk of ground rupture in the event of an earthquake. The risk of landslides near the project site area is relatively low, since this area has very few steep slopes. Landslide risk is determined by steep slopes that have 25% or greater incline, soil series data, and soil susceptibility. For the construction of this roundabout, it is recommended that the soil be excavated and filled. It is because clay makes up more than a third of the soil properties for greater than 3 feet in depth. This means that the soil in this area has low strength due to shrink-swell characteristic of the clay, causing concern for roadways. Filling the excavated soil with a more aggregate-based soil will produce a long-lasting foundation for such a heavily trafficked road.
Hello, I'm Phil Veliker, and I am the roadway engineer and CAD specialist. Our project site is located in Ramona, California, at the intersection of State Route 67 and Highland Valley Road. The SR 67 is a 2-lane rural highway with 12-foot traffic lanes and 8-foot shoulders. At the intersection, there are 12-foot left turn lanes in both the northbound and southbound directions, as well as 12-foot right turn lanes. Dye Road and Highland Valley Road are 2-lane county roads with 12-foot through lanes, 1 12-foot left turn lane, and 8-foot shoulders. The intersection is signalized in all 4 directions. Highland Valley Road was realigned to its current location at the intersection of SR 67 and Dye Road in 1992. Since the intersection's construction, a pattern of excessive queues and rear-end accidents had been identified. This led to the construction of the right-hand turn lanes in January 2000. Further adjustments were made in 2009 and 10 to reduce queues on SR 67, but traffic delays have continued to increase and can extend over 3 miles on the northbound SR 67 during peak afternoon traffic. Using the SAMDAG regional transportation model, Caltrans traffic forecasting branch analyzed traffic for the area and projected the level of service and vehicle delay in the year 2040. If nothing is done, the level of service will fall to an F and delay times could double. Our solution is a 2-lane roundabout at the SR 67 Die Road intersection. Our design includes a road widening at each of the 4 approaches to accommodate 2 entry and 2 exit lanes in all directions. Although the average volume of cars entering or exiting the roundabout at Die Road may not call for 4 lanes today, Caltrans has assumed that much of Die Road will be constructed in the next 20 years, and the developments of Montecito Ranch and Cumming Ranch will be built out. The roundabout will operate at an entry speed of 30 miles per hour, allowing for the greatest allowable traffic flow for a rural multi-lane roundabout. The roundabout alternative provides many significant advantages over the existing 4-way signalized intersection. Not only will delays be cut shorter, but safety will increase. Noise, air quality impacts, and fuel consumption may be reduced. There will be no signal hardware or equipment maintenance, and the roundabout and landscaping along with it will improve the aesthetics of the area.